Hello everyone. So let's start. Who's got a robot at home? We've got 1, 2, 3. So has everyone got a dishwasher at home? Yeah, so everyone's got a form of robot at home. Or you've got a dryer or, washing machine. They're all robots, but they're very specific machines, aren't they? Do a specific job. Today's more about AI-powered robots, so ones that are more generalized. So yeah, as we go through it, you'll see some of the things it can be used for at home, also at work. So let's go to the next slide. So I've worked in manufacturing for the last 14 years. We've got robots in the factory that move parts from one location to another, weld, and they're very specific sort of robots. They've been programmed to do a particular type of job, so not being AI controlled. And my passion is that physical world and intersection with the virtual world, so using sensors to understand the world. And I've been doing AI, IoT and robotics for the last 7 years at work and also at home. And as part of my hobby, I go to Sheffield Hackspace. It's just where a bunch of people who are into hardware and programming just go to sort of mess around and play about with different hardware. I've created little robots that just rove around before generative models came out. Yeah, and I've got a little blog if anyone wants to sort of look at that, just where I've just got my doodles, my thoughts out, yeah. Okay. So my aim today is not to sell you anything, but just ideas. So I hope that everyone goes out and buys a robot today, an AI-enabled robot. You can get the kits. I'll tell you how to get the kits, a bit about how to build them, how easy it's becoming, and also a bit about the economics of it as well, and why we want more robots. And more importantly, why things are changing now. You've probably got the idea. AI is going to be a big theme for this. So the cost efficiency. So robots, if you've got, so say you've got a manufacturing line and you're making sandwiches, if you've got to pay someone to make those sandwiches, it's going to cost a lot. And that's going to come out of your pocket. So if you can get a robot to automate that and make those sandwiches for you, it means the price of your food is going to come down. And the same in agriculture as well. If you've got to pay someone to go out and pick the leaves or pick the grain or whatever, and also the pesticides, as a health side, because you could have a robot that goes out and cleans the plants or ejects the ejects the...
Alrighty, ladies and gents, we're going to be starting the quiz in just a couple
of minutes. Okay.
If you could please put your team names on your answer sheets.
Okay. Yeah, so if you need to weed killer, rather than just blasting weed killer all over the place, you can just do it specifically to where the weed killer needs to be. So it's going to be a lot more healthier in that respect. So it's going to be a lot more cost efficiency saving if you can get a robot to help you out with that. So and the other side is it's going to be time saving as well. So if you've got a task that's very repetitive, that just annoys you, it means you can free time up to do that. So like I mentioned at home, we've got things like washing machines, but it doesn't empty the washing machine and hang your clothes up for you and then put them in your drawer. It's only doing part of the job. So if you could do the whole pipeline for you, that'd be fantastic because it would free you up to go out. You wouldn't need to be staying to do certain jobs. So it just frees a lot of time up for you. So these are some of the things that you can do for yourself. And also, if you make your partner happy as well. I know my partner's much tidier than me. She wants to do stuff straight away as soon as the tasks need doing, like cleaning up, tidying up and all that kind of thing. And I'm like, nah, we'll leave it a bit longer. But if you had a robot, it could do it while you're asleep. It could do it during the day while you're at work. So there's a lot of room for helping around the home. And also, we've got to be competitive as a country, as a region and as a city. We can't... It's all right. I don't know if we can get that turned off left later on.
So usually I would say your first answer would be around the answer. This week, If you say it within 5 minutes, then we're going to swap your answer sheet with.
I'm guessing you can't hear me talking over that. It's a bit annoying. Yeah. Well, I know.
So if you do put an answer down and you change your.
So what would people want automated in their home now? Ironing? Yeah. Do you iron now? Oh, yeah, that's annoying, isn't it? Yeah. You wouldn't have those arguments, would you? Have with them just because they don't want to tidy up. You just get the robot to do it for you. That's it. Yeah. Read more books with them. Yeah. Perfect. Anyone else got any other tasks that they want automating that annoy them? Yeah, that's a good one. Hanging washing. Yeah, folding clothes and putting them away as well. Yeah, that would be good, yeah. You could just chat to it and it just stopped. Okay, is that off now? Or? Should be, okay, cool. I'll carry on. Okay, yeah, so these are some of the tasks. Cooking, would you want that automated? Some people nodding, some people, no, I like it, I like cooking. Maybe you just want it automated during the week when you've been at work, but weekends when you've got a bit more time, you do it yourself. And no, got a no there, definitely not, no. Pizza in the oven, yeah. Shopping, you can get that delivered, so it's semi-automated, but if you could get someone to go around the shops for you, pick the bits that you like, so it's personalised a bit. Sometimes if you get it delivered, the fruit's not always the fruit that you want. If you could just get someone to go out there and do it for you. Household cleaning we've touched on, dishwashing, pets care as well. I've not got a pet myself, but so you can see on this chart. So the bottom bit is how much time we spend on, and then the y-axis is how likely it is to be automated. So cooking is right up there as the ones that could be automated. And there's lots of robotic arms out there at the moment that are being sold to automate this. So the UK, we're trailing behind. Look at us there, right at the bottom. But if you look at the bottom right-hand chart, we are on the right slope, so we are getting more robots. So yeah, the UK hasn't got that many robots. We've got a lot less than our partners. But things are going to change, I think, because of AI. I think you're going to see far, far more. So these are some of the tasks, like I was saying, washing up. You can do it yourself. Do you need space for a washing machine or a dishwasher? If you've got a robot that can do it, you might need to be able to get rid of that, free up space.
If you just hold yours a bit quiet, closer, it should drown out.
Okay, cool. Yeah. So, yeah, you could have a washing machine. You free up space. It means you can have extra things in your household. Cleaning. You've already got robots that clean at the moment. So you could have more of those. But the problem with the ones out there at the moment is that they're not very clever.
Guys, let's get to it.
I'll wait until they stop it, because I don't think we can do it with two voices on. Yeah, so they're not very clever. I wonder whether my voice is going up there as well. They're like, what's to say I tagged on about? Okay, that sounds all right, doesn't it? Okay, yeah, so the robots aren't very clever. They don't go upstairs. They only can go around certain parts of the house. They're not very efficient in the routes they make. So a lot of improvement there that AI can sort of help with. I've also got a robot lawnmower myself, and it goes out, it cuts the grass every day, and it works quite well. But it doesn't do the gardening, it doesn't cut the hedges, it doesn't dig up, it doesn't plant. So that's some things that could be automated. So the traditional path into robotics is use the mechanical, electrical engineering. You'd have to have very high precision, manually programmed motors. So the motors would have to actually go over and know the precise coordinates to pick up the cup. if it doesn't know those coordinates or the cup moves, a lot of these robots wouldn't work. So the new paradigm that's coming is you have cameras that guide it, and imagine a ball coming over, you're catching a ball, and you're always just sort of moving your body slightly just to make sure you're catching it right, and you catch it last minute, you sort of fine-tune your own movements. And that's what the AI is coming in to do. So what that means is that the motors that you need don't have to be as precise as what they used to be, because you've got that fine-grained tuning as the object gets closer and closer. And the typical paths that are going through as like an AI engineer and computer scientist. You do have computer scientists in the traditional path, but it's getting more towards a computer scientist's skills now. So this is Hugging Faces, one of the engineers from Hugging Face. This is an ex-Tesla staff, and he was the head of Tesla, I think, in France. And this has been trained on I think it was 50 attempts. So he's shown the robot 50 times what to do using these robots at the back, which we'll show in a minute. And it's able to do it himself now. And it's able to do it every time as well. So with 50 examples, and this is 50 examples is quite a lot at the moment, but this is going to come down very quickly. You've seen how good language models are, like ChatGPT when that first came out. It was okay, but if you use it now, it is really good. And the same thing's happening with these models too. They're actually piggybacking off a lot of the vision language models that are coming out at the moment. They've just got some fine-tuning that's going on. I'll tell you a bit more about Hugging Face. So does everyone know what Hugging Face is? Has everyone heard it? Got quite a few nods. Okay, so it's a website or a company, and they provide lots of material and resources for learning machine learning. They've got lots of libraries that help you train models. They've got lots of models that you can download, so the weights of the models, so that's the actual brains of the models. And they've got lots of AI researchers on there posting papers and just educating you. And their aim is just to make sure that they've got a big platform that's open source, that anyone can go on and learn and use AI. They want to be the place that everyone goes to learn AI. And they've got a new robotics team called Le Robot. It's in France, and hence the Le Robot. And they've got quite a good team, and you can contribute to their sort of library and upload your own models, your own training data. And that's the big power, I think, that the training data that you can upload. So as you download and create your own using cameras, just standard cameras, or you can use phone cameras to record the robot doing something, and then you can upload that training data to Hugging Face, and everyone can access that training data. So it just means that there's going to be a peripheral of lots of training data to train your models. That's not necessarily you. Someone else might train a model and then provide the weights for that model, so the brains of that model that it's been trained on, and then you can use that model to do an action yourself. So the big competition is ROS, and who has used ROS here? Robot Operating System. We've got two. Do you like it? Big no. It's complicated, isn't it? It's really complicated. Yeah. Sorry, what's the last bit? Oh, right, okay. So is it? Oh, I've got the company name. Oh, yeah. So, yeah, it's really complicated. The architecture is very difficult. It takes a while to learn it because you've got to understand the various different programming languages. You've got different microcontrollers. You've got full-blown PCs in there. You've got single-board Raspberry Pis and that type of thing. And there's just lots of pieces to coordinate, and it's just very difficult to learn. So the robot came around and said, "Okay, how can we change this?" And what they've done is just got a big model, one software library that you download. It's all written in Python. You clone that down, and then you just plug in the devices that are USB and start recording. So the inputs to the models is the vision element of it, so your cameras, and then the output is the motor positions. So that's all it's doing. It's just predicting a path, output path. And it's just so much easier to sort of use. There's a little bit less control in some sense, but it just simplifies the whole process. So these are two of the robots. I've actually got the very early edition. So I bought these when it first came out, and they're not the best ones to get. This is the Koch robot. It's a bit more expensive and it's not as good. But the SO Arm 100 was done by someone who was on the Discord forum. He just contributed to it. He just said, okay, I can design something better than the Koch and I can do it cheaper. And he's done it, and he's uploaded everything to GitHub, and you can download all the models, so the 3D models and the actual part list, and you can actually print these and insert the motors and just build them yourself. It just comes as a kit, and it's just excellent. And then Jess Moss was an employee of the robot, but I don't think it's as good. It's not as got a good traction. The difference is that you don't need a 3D printer for that one. You can just buy the components online and just hook them together. So I think it's actually less than 250 now. I think it's £110 I got it to. So £110 per robot. So you need a leader and a follower. But you'll see later that the working out ways you don't need a leader and a follower. All you need is the follower that actually does the task that you needed to do. I'll get into what the differences are between them later. So this is how you train them. So this is what I was saying. So you've got someone on the left-hand side controlling the robot. You'll have cameras looking at the robot on the right-hand side. And then it records what you're doing and it learns what your goal is. And then it'll be able to do it itself. And like I was saying, you don't need that many iterations just to learn, to teach it to do things. So if you want to, I'm going to make these slides available offline so anyone can download them. I think this is a Disney robot. So you can download this, 3D print the parts, build it, and they've got data sets, they've got models, and various different things so you can get up there working quite quick. And it can do whatever this robot does. I don't know what it does, I think it just walks around, but... So one of the problems with robotics is grip. So if you see manufacturing, they've got various different grips. So this guy is working using like a tendon, more like a human, muscles work to get the grip. And this is the same guy who developed that other SO100, the robot arm. And it's all open source. It's got sensors on there to detect when it actually grabs something as well. It's quite innovative. You can see it doesn't look great at the moment, but it's open source and it's a start. And I think this is going to be another big area as well, teleoperation. So you can actually use something to control a robot, so you can train it to do what you need it to do. So you don't have to buy a second robot just to get involved in this. So if you've got an Xbox controller at home or something like that, you could just probably use that. But that's a working area. So what do you need? I've already sort of gone over this a little bit. So I've run it on this laptop here, which is 4GB GPU. So you need that for the inference. So to process the images that are coming from the camera and then sending the output to the motors, the position where the motors need to go to. And it sends that plan out to them. All you need to do is clone the GitHub repository and then run some Python scripts. And then some configuration files. So it's I can't remember what the type of configuration files are, but it's just changing some text values to whatever robot you've got, what position, what motors are, what positions they are, and that's all you need. And then just join all the motors and wires together. It's a bit like Meccano. So more advanced skills, 3D modeling, but 3D modeling these days is getting a lot easier. Like you can use AI for programming. You can use AI now to start generating 3D models or to help with certain tasks in creating models. So I think that's going to get a lot easier. So I think there's not just growth in the AI side of developing models for action planning, it's also models for designing a robot as well. And there's loads of different designs you can choose for robots, like ones that go through pipes like a snake. I think it's going to take a lot of imagination. There's going to be a lot of imagination. You can use, if you've already got data science skills, you can use various different practices that you use for training your models, reinforcement learning, so you can create your own virtual environment and then train the model within that environment, so in a computer essentially. And any papers that you've read, you can incorporate those as well. And Python as well to update and add to the library. So I've actually done a few pull requests, mainly documentation to the robot, because it was very early in the project when I first started, and the instructions wasn't for Windows, they were all for Linux, because that's what developers had. So yeah, you just create a pull request and you can update the documentation. So imitation learning, that's what we've gone through. That's where you can sort of control a robot. So hopefully I get time to do it. You can just control a robot through here. And then the other side will move, and then you'll have the camera recording the robot doing whatever action you want. So picking up a cut, placing it somewhere else. But it could be anything. It could be making a sandwich or folding clothes or whatever. So reinforcement learning, I think this is going to be a big area. The reinforcement learning is where you've got a goal that you want to reach. You've got a starting place, and then you've got all this middle bit where there's lots of different options you can take, and the model will get rewards getting close to that goal. So that goal again could be putting an item in the cup. So it just measures the distance of the error that you've got, and then just update the weights accordingly to nudge the model in the right direction that you want it to go. So putting the object in the cup. And you do it in a virtual environment, it could be 100,000 times the speed, even more. And when you take it out of that virtual environment, you might need to do some fine tuning on the real world, because you've got some motors that are slightly not working as depicted in the virtual world. But they're getting a lot of success in that. And then some of the other things is you can use video models, so using things like Sora or some of the other models. You can generate outputs of what you want to actually happen. So you could just type a prompt into Sora, say a robot picking up an object. That'll generate a video. You've got part of your training data then, that you can include in there, just to give it a bit more distribution for the data that you're putting in there. And then they've got physical simulations that you can use, which is NVIDIA Isaac simulation, which is by NVIDIA. So that's something that models the real world. And it's got lots of objects that you can put in there and sort of manipulate, and it's a whole sort of world in itself. But once you've got a robot in that position, you can train it on that. So yeah, it's not necessarily reinforcement learning, but that does add to that world as well. So there's two types of models that are used at the moment: diffusion models, and that's the main one that's built into the robot library. If you've used any of the vision generating images, they use diffusion models. So language models at the moment, like ChatGPT and all those, they predict one token or one word at a time, whereas diffusion models predict the whole thing from noise, and then iteratively get better and better and better. So in this response, they'll take the video image, and then from that noise, they'll generate a path for the robots to go in, for the motors. But you can use VLMs as well, which are robotics. So they're the sort of the language models that use at the moment, transformers. But they use a lot more resources, because transformers just take a lot of memory to run. So if you're running them locally on a laptop, it's better to use a diffusion model, because you need less resources. So this is a new VLM that's been created. So you've got models out there that have been pre-trained on lots of different robots. And what they've done is they've taken they've took a SIGLib, which I think is Google's vision language model. And then they've took Gemma 2, or Gemma, I don't know which one it is actually, which is a language model. And then they've made sure all the sort of, make sure that they're both aligned to each other. And then they've also trained with the data set here, which is all purely robotics data and internet training data. And then they've passed it through the model to train the weights. And then they've added an extra section to predict the coordinates that the robot motor's going. And this is where I'm saying they can piggyback off the existing infrastructure that's going on at the moment in just normal language models. So there's billions, millions, we're talking trillions, aren't they, being spent on these language models. And robotics can make use of those. So that's why it's going to grow quickly. So, yeah, audio robots now. It's just getting started, so yeah. I've got a choice now. I don't know how much time I've got left. Okay, so we've got a few extra slides to go through, or we can just fire questions. I don't know what the sort of format is. Any? Any questions, then?
We only have the one microphone, I think.
Hello there. I saw in the press some months ago about some Japanese personal care robots designed to replace or support people in old people's homes and things like that. Are you familiar with that? Yeah.
They've been out for about 10, 15 years, haven't they? I don't know where. Yeah, they've been out for about 10, 15 years. Yeah, so I can remember going around one of the university labs, and they had them over there. So yeah, they've been around a long time. I think what we're getting now, though, is personalized robotics, because you've got the language models in there. So I think that's going to be the next stage. And also the actual, what they can actually do is going to improve. So they can actually do something useful, not just, emotional side of things as well.
Yep, over.
Hiya. I was wondering, it's weird to hear my own voice, but what other sensors are there for the robot apart from the cameras that's available?
What sensors would you like? That's the question. Can it any sort of input you can put into the model? So you could have an infrared sensor, you could read ultraviolet, you could. There's all sorts of different sensors that you can get. Like on the robot hand, where add sort of textile sensors, so you can sense touch. So anything that you want to feed into a model, you can do, and it just sends a fusion into the model. You just train it. So yeah, it's whatever you want in there. Maybe you want some IR sensors for distance, but with two cameras, you get the same effect. So that's one of the things they found. I've got here two cameras that attach to each other, and this is a 3D vision camera. But you don't actually need it. All you need is two cameras, just standard cameras like that, or a camera on your phone, pointing at two different angles, and that's enough to create a 3D perception, so the robot can do what it needs to do. But like I say, you might want something that works in the dark as well, so you can get something like that. Might not even need to be RGB, might just be grayscale.
I just wondered what the most interesting robot is that you've built.
Most interesting robot.
I think it's got to be this style of robot, just because of what it can do. I have built robots that rove around, but they don't do much. And I think this has got some real applications. Especially when it gets a bit further into it. I've not touched it for a couple of months, just because the job that I'm in at the moment, I've got to find a new job, so I've just been looking for work. But this area is moving so quick, and I think robotics is moving so quick that I think just this style of robots very functional.
What do you think would be like the first properly consumable robot that people will actually, like everyone has washing machine, right?
Yeah. I don't know. There's loads of like Unitree have got some robots. Unitree, the humanoid robots. You've probably heard of Tesla bots, and the humanoid robots. They seem to be coming on quite well at the moment, and they're designed for humans to operate in a human world. So they're built the same height of us. They've got the same arm length. They can walk around the same places we can walk around. It's got all the training data, because they've got the same limbs as us, to move in the same coordinates. So from an AI perspective, they can be trained relatively easy just on, say, YouTube data.
Okay.
Hi. When you mentioned the folding clothes robot, my understanding was that they trained the model specifically for that task. But when we talk about things like training these for example, the large language models, they've taken an extremely large amount of compute to do that. So when you talk about these specific tasks, does it take a lot of compute power to train your robot enough to do these individual tasks?
No, not all. So the diffusion models can be trained very easy on very small laptops. So 8 gigabyte VRAM, 480 or 490 sort of graphics card. The other one that I mentioned, which was this one, so it's called Pi Zero. That's a pre-trained model, and that's been using Gemma 2.6 billion parameters. So that is one of the models that you talked about. It's a language model that's 2.6 billion parameters. I think they say ChatGPT GPT-4o is 1 trillion parameters, I think, if I got that right. So there's open source models that are reasonably, sort of nearly on par with GPT-4o, not that far away. So there's no reason someone can take one of those models, train it on all this data that's custom made for robotics, and then for this part, which hasn't been trained yet, just fine tune it. So I think there's going to be a lot of leverage you can get from the models that are being open sourced in, for language models and the vision language models. Right, okay, sorry, I'm probably, so fine-tuning just means that you're taking a pre-trained model and then you're just training it for your specific use case. So you record your task maybe 5 or 6 times, and then you can train on that. That's no problem. There's a lot going on in this area, so yeah. I'll get you the microphone, 1 second. No, you're right.
Hi. First of all, thank you so much for your presentation. I think we're really resilient with maybe some of the chaos going on, so thank you. My question is, you talked a lot about the opportunities with robots. I was just wondering what the risks are. It felt like maybe AI grew without much, maybe I'll say regulation. Is there an element of that within robotics? Is there stuff we need to be maybe preemptive about? It's a big question, sorry.
There's I think you've got to be worried about it in a sense, because you're building something that's got some autonomy and that's working in the world. So you've got taxis that are running over in America in certain cities. If they ran over someone, that would be a problem. So there's lots of laws that are being created to sort of make sure that doesn't happen. And I think you'll find the same thing within companies, whether it's an office or a manufacturing site or whatever. But a lot of the robots arms that you find in factories now are called cobots, and they can be stopped at any point just by touching them. So they have got some safety built into them. But then you could look at the other side of it, war. You know, if you put these into a war situation, you know, how humans act, all that kind of thing. So yeah, there's a lot to discuss in that area.